Number one, find DF. Remember, anytime they say something like find AB and it doesn't have a symbol, array symbol, line symbol, or segment symbol, then they're saying find the length of the segment. If D is between E and F, so you got to draw your picture. What goes out here on this end? How about on the other end? And we put D somewhere in there. ED, so from E to D is 6x minus 4. So we mark that. D to F is 3x plus 5. And the whole thing, EF, 46. So we've got it labeled. Once you have it labeled, if you walk from here to there, and then you walk from here to there, how far did you walk total?
46.
46. Or this plus this, right? So this plus that right there. So we could set up an algebraic equation. 6x minus 4 plus 3x plus 5 should equal 46. Collect like terms. Some people, if it helps you, split it up at the equal sign. I know when I taught algebra, I always taught to split it up at the equal sign, because if things are on the same side of the equal sign, you don't do the opposite. You just put them together. Okay? So the 6x and the 3x are on the same side. Well, we just put them together and you get 9x. That takes care of those. The minus 4 and the positive 5 are on the same side, so we just put them together. You don't do minus 5, minus 5. You just put them, collect them together or combine them together. Well, a negative 4 and a positive 5 give you how much?
1.
Positive 1 plus 1, that equals 46. Subtract 1 on both sides. I'm going to do this sort of quick because I'm running out of space here. Subtract 1 on both sides, you get 9x equals 45. Divide by 9, what's x equal? That's not our answer. Why is that not our answer? What did they find, or what did they ask us to find? Length of segment DF. So we go back up here to DF, that's this part. We want to plug in right there. What's 3 times 5?
15.
Plus 5. So DF, boy, that looks terrible. DF equals 20. Next one, precision. Remember 3 things on precision. You find the smallest unit, take 1 of that smallest unit, and then multiply by a half, or 0.5. 24 meters, what's our smallest unit? A meter. And we want 1 of them, so 1 meter times, this time instead of multiplying by half, we'll multiply by 0.5 because it's the metric system. What's 1 times 0.5? Say it again. 0.5. That's our answer. That's all there is to it. That's the amount of precision. That's how accurate our measurement is. We expect that this measurement is within a half meter one way or the other. Now you could have explained it out and wrote that we then expect that the actual measurement, even though this 24 meters probably isn't exactly right, we expect that the actual measurement is between 23.5 meters and 24.5 meters. But this is the actual number that they wanted. Next one, how about a calculator? Help me here in a second. That says find RT and they give you ordered pairs, then you know you're going to use what formula? Distance formula. All right, if you're finding a length, you're going to use distance formula. If you're finding, what's it going to say if you're using the midpoint formula? Find the coordinates of the midpoint. So for this, the formula every time, I'm going to go ahead and write the formula. You know, my thing's messing up here. Need to recalibrate it. Subtract the x's, square that answer, subtract the y, square that answer, add the two of them together. I know I'm not going to have room to do all this on here, so we're going to try to switch a little bit in, or scrunch it in. What's our x coordinates this time? -2 and -3. Remember, the x coordinate's the first one in the ordered pair. So -2 minus a -3. What's the y coordinates this time? 5 and -6. Good. So 5 minus a -6. On both of these, when you have minus and negative, what can you do with the signs right there? What is -2 plus 3? Say it again. 1. 1 squared. 1 times 1. 5 plus 6. 11 squared. Look over here if you're not sure. You don't remember? You know that's 10 squared, right? So what is it? 121. What's 121 plus 1? 122. 122 is not a perfect square number. Somebody on their calculator, help me out. What's the square root of 122? So what's it say? 11, because they want us to go to the nearest 10. So that means we got to round it off 1. Say, what is it again? 11 point.
0, 4, 5, 3, 6.
So 11 point. Now a lot of people just wrote down 11 because it's 11.0. Is 11 and 11.0 the same answer?
No.
No, because if you write down 11, that makes somebody think that you've rounded it off to the nearest whole number. If you write down 11.0, does the next person that looks at this know that you were being pretty accurate because you were going out farther?
Yeah.
So even though that 0 doesn't really mean anything, it means something as far as how accurate we're being. What are we going to use on this one? Midpoint formula. Midpoint formula looks like this. Add the x's, divide by 2, comma, add the y's, divide by 2. Two separate answers. Distance formula, you get one answer, one length. Midpoint formula, you get an x coordinate and a y coordinate. What's our x's this time?
3.
So 3 plus -3 divided by 2. What's the y coordinates? -5 plus 6 divided by 2. Let's just do all this math all at once. What's 3 plus -3? 0 divided by 2?
0.
That's the x coordinate. 0. You don't do anything else to that. That's your x coordinate of your point. What's -5 plus 6? 1 divided by 2? 0.5 or 1/2. Got two separate coordinates. It's a point. So if you were to look at the graph, the original points were 3, -5, 3, -5, somewhere about in there. We'll say, just estimating, -3, 6, -3, 6, somewhere up in here maybe. That's our original segment. Up here we figured out how long that segment was. Now we're trying to find what's right in the middle. Well, we said 0, 1/2. 0, 1/2. You think that point right there is somewhere close to the middle? Yeah. All right, that's what you're finding. You're finding the point that splits that segment into two congruent segments. Last one, how many planes appear in the figure? How many planes do you think? 6, everybody agree with that?
Mm-hmm.
Somebody else think something different? Don't be a chicken. Thought 5? I accepted either one of those answers because with this, Can we tell for sure that there's a top here?
No.
No, it's sort of hard to tell. Somebody, I did learn something the other day though. Somebody said, yeah, you can tell there's a top. How can I tell there's a top there? If you look at this right here, that little segment back here, what kind of segment is it? It's dotted. That means anytime something's dotted, what's that telling you? It's behind something else. Well, the only thing it could be behind is the top. I always took the answer as 5 or 6 because I didn't think about that. But somebody explained that to me. It's pretty good that they picked up on that. So I accepted either one of those answers. All right, today is the, what is today? Second. Today's the second. Go ahead, start copying this down. Remember, put your blanks out here. Yep, before, after, effort. So, Julie, you're telling me right off the bat that your effort's going to be like a 1 today?
Yeah, pretty much.
It's not a good thing.
I'm tired.
Me too, but.
Are you recording? You are recording right now.
Yep. So everybody watches this is going to know that you're not putting any effort into it. That way, somebody comes and says,
I feel like I did
why's she not doing well in this class? I said, well, let's watch this video and see what effort she says she's going to put into learning. Well, we're going to cover today, angle measure, be able to measure and classify angles, identify and use congruent angles. When you're, as you're writing this down, classify an angle and naming an angle, 2 different things. When you name an angle, you name it with letters and symbols, just like we've been naming segments and lines and everything else. Classify an angle is what you learn to do in like 3rd grade or 4th grade. Well, give me a classification of an angle. What's something that you classified an angle as when your teacher taught it to you before? Nobody knows?
I don't know.
I guess we'll learn here in a minute. So right now, which of these blanks could you fill in right off the bat? The B. So how much do you know about angle measures and measuring and classifying angles, do you think? 2? So we could fill that in.
I put 1.
1.
Yeah, but I don't know anything.
You have to put what I put up there on the board?
No.
No, yours, everybody's going to be different. What do you use to measure an angle? Protractor, what's it measured in? What kind of units? Degrees. What's congruent mean again? Same. Same measures. Anytime you're talking about congruent, same measures. All right, so if 2 segments are the same, they're the same length, right?
Sorry.
That's right. If 2 angles are the same, they have the same degrees.
You're gonna get 5.
All right, write these 3 things down. We'll give a brief explanation of each one.
Off the board.
Now, when you talk about a degree, we're going to, and this isn't a good definition or anything, but we're going to use degree as the unit to measure angles. It's a unit that we use to measure angles. It's not a good definition. The actual, what a degree is, when we're using degrees, and regardless of what kind of degree it is, whether it's a degree for an angle, degree for temperature outside, whatever it is, they all mean the same thing. They all started from the same place. What a degree is how much of a turn something makes. All right? Now, most of you, when you look at a thermometer, it's what kind of thermometer now? It's like digital, right? Just gives the numbers and nothing else. Well, thermometer started off, you might see one of these at your grandma's house or something hanging out on the barn or on a tree or somewhere, and it looks like this. Looks like a clock almost, right? And what it does, probably the hand's probably actually down here, but what it does is that rotates around as the temperature goes up. And that's why it's degrees, because it's measuring how much of a turn that hand makes. Same thing for an angle. Yeah, if my angle starts off like this, we're measuring how much it turns as we go. That's all degrees are. A ray looks like this. What's different about a ray from segments and lines that we've talked about already? It only goes one direction. Now, when we name a ray, the symbol for a ray, this is real difficult again. What was the symbol for a line? A little line. What was the symbol for a segment? A little segment. Guess what the symbol for a ray is? A little ray. Nothing hard about any of the symbols that we use this year. So that's the symbol. When we name it, you got to be careful. With a line, it didn't matter. With a segment, it didn't matter. Line, you could pick any 2 points on the line to name it. Segment just had to be the 2 endpoints. Array, it sort of matters how you pick them. What do you think? What letter has to come first here? Q. What it does, it shows the direction. Array has a direction. A line goes in both directions forever and ever. A segment ends in a certain spot. Well, a ray goes in one direction forever. And when you name it, you show which direction it's going in. So how would I name, let's just do something like this. Let's make a line here. Name me a ray in that picture. Say it again. NS. So if I name ray NS, if I name ray NS, where does that ray start at? Starts at N, and it goes out that direction through S. Name me another ray. M N. NM. So that starts at N, goes out that direction, right?
Can we put 3 in there?
Now, don't put 3 letters in there because then that's something completely different. Now, could you do this? Where's ray MS at? Starts at M, goes out that direction. Is that the same ray as ray NS? No, it starts at a different spot, right? So ray MS includes all of this in here. The NS didn't. Now, does it share some of the same points? Yeah, because they both go out in the same direction. Give me another ray on that picture. S, say it again. SN. Starts here, goes out this direction, Would SN include the point M? Yeah, it goes out through it. Now, when you name it, do you put that point in there? No, you don't have to. Opposite rays. What do you think opposite rays are?
Opposite.
So what do you think two opposite rays are?
It doesn't have the arrows.
It has ears. Two rays that are opposite of each other. If I have this pin as one of my rays, and this is the other ray, how do you think they're going to be? Like this? Opposite rays would be what? Where they go end to end, but they go out in opposite directions. So what's two opposite rays going to form together? A line. So let's write that right here. Anytime you have two opposite rays, they form a line. Name the two opposite rays in my picture so we can write it down. Be careful. Ray what? Ray BA and ray BC are opposite rays. Somebody said AB at first. How come AB wouldn't have worked? It's going that way, right? You need it to go the other way. So what they got to have, the opposite rays have to have the same starting point. Opposite rays will always have the same starting point, and they go in opposite directions. So same starting point, and they go in opposite directions. Hopefully you have some idea what an angle looks like. I'm just going to draw one up here. An angle is two rays with the same starting point. Two rays with the same starting point. So two rays that have the same starting point. That's what an angle is. Notice here you have your starting point. This ray goes out this direction. This ray goes out that direction. How about these two rays up here? Do they have the same starting point? So is this an angle? Yeah. It's a special kind of angle. Anybody know what special kind of angle that top one was? What special name do you give this angle? It's another angle. Straight angle. Good. It's a straight angle. Now it's a line, but if we wanted to measure it, can you measure a line? No. You can measure segments, but you can't measure lines, right? A straight angle, we can measure. Anybody know what the measure of a straight angle is? 180 degrees. All right, draw this picture, write these terms down. We're going to go over parts of an angle real quick.
Wait, isn't it like if the line just keeps going, it doesn't turn, right? So like it would have to end up in the same place.
Well, sort of. You're not, remember, it has to start somewhere, right? So with a straight angle, you're saying, all right, we started off with this. We started off with our things like this, right? And it started turning until it got to what? I can't do my arms that way. They don't bend, right? You see how it ended up? So it started and it turned and it kept turning until it got, if I could draw, I can't draw it very well. It got to where it went in the opposite direction that it started. So that's a straight angle. So you're still measuring a turn, but it's like half of a circle. That's why when you stand here and you turn 180 degrees, that's what you've done. See how I'm pointing this way now? So that's my ray. If I turn 180 degrees, now this is my ray. So it forms a line. Vertex of the angle. Where do you think the vertex of the angle is? Does anybody know that part? Vertex of the angle is where the two rays come together. So in this case, the vertex is point T. Point T. Vertex is where those two rays always come together. What are the sides of an angle? We already said it. What are they? What is this over here? TA, what is it called? A what? A ray. So the sides here are two rays. One of them is ray TA, and what's the other one? Ray TB, good. What do you think the interior of the angle is? Inside, right? So I'm going to do this. All this stuff, that's the interior of the angle. However you show it on your paper so that you can understand it, doesn't matter. That's all interior. How about some point out here? Is that on the interior of the angle? Yeah. Yeah, because what happens with the angle, with the sides? They keep going on forever. So anything that falls in that range is going to be on the interior. Where do you think the exterior is at? Where's it at? Outside. So all this stuff, exterior of the angle. So all this stuff out here. So I'm talking about this rectangle right here. Which one do we care about more? The interior of the rectangle or the exterior of the rectangle? The interior. And that's what we're going to deal with most of the time in class, is the interior of the angle. There's too much stuff on the exterior. Is this point out here on the exterior of the angle? Yeah. Is it inside the angle? No. So there's a lot more exterior stuff and we don't deal with it a lot of the times. Every now and then. All right, these are ones that you should know. Let me get this switched. Go ahead and start writing them down. Right angle, acute angle, obtuse angle, straight angle.
Okay.
You can still be writing those four, right? You can't remember? Right, acute angle, obtuse angle, and a straight angle. We're going to start with the right. If you start giving your own definitions, that's fine. Just know that you're probably going to change two of them, because what you write down is not going to be completely correct. What's a right angle? Right, has a measure exactly 90 degrees. Measure 90 degrees, exactly 90 degrees. Let's jump down to a straight angle. We just talked about this one a couple minutes ago. What's the measure of a straight angle? Measure exactly 180 degrees. Now, all of these are the words that I tried to get to earlier. Everybody's too tired to answer me. These are the way you classify angles, all right? You say, hey, I have an obtuse angle, I have an acute angle, I have a right angle, I have a straight angle. classifying. Not naming, classifying. When you name an angle, we use letters. Anybody know what an acute angle is? Something smaller than 90 degrees. That's the definition that Levi learned from some teacher in the past. And they didn't tell you the complete truth, Levi. Alright? Because that's not completely right. Alright? An acute angle is an angle that has a measure between what two numbers do you think it's between? 0 and 90. Now you use the word between, so do you have to go, oops, hang on, keep running out of space. 0 and 90 degrees. You don't, when we say it's between 0 and 90 degrees, if I say that Robert is between me and Julia, that works, right? Now, am I between me and Julia? No, because it doesn't include the ends, right? So here, does it include a 0 degree? Does it include a 90-degree angle? No. What do you think an obtuse angle is? Say it one more time. All right, has a measure between 90 degrees and 180 degrees. Again, your teacher in the past probably told you an obtuse angle was, well, they may have told you that one, and they may have told you right on. The acute angle is the one where you've got to throw in that 0. They didn't tell you that. There are negative angles in the world. We won't talk about them, but there are things that you could deal with negative angles. Because again, you're talking about a turn. So if I'm standing here and I turn this way and I tell you I turn 90 degrees, makes sense, right? Now what if I'm standing here and I turn this way? What do you think I turn? Negative 90 degrees, because I turn opposite. With stuff that we deal with in the real world, does it matter which way it's turning? Yeah. It's going to make a difference, right? If a wheel's turning one way or another, makes a difference. You got to know that. So that's why we have positive and negative angles, all that stuff. All right, what we're going to do on that scrap piece of paper, set your notes off to the side for a minute. On that scrap piece of paper, you're going to start doing this. Number 1, draw an angle using your ruler. So draw an angle, make it sort of big. That's all you're going to use that scrap piece of paper for. So if you make some little angle that looks like this, it's about that size, then it's not going to be big enough. I know you can't really see that.
It doesn't matter which kind.
Nope, you make whatever angle you want. I prefer you didn't make a right angle, just because that's going to be confusing to you. So make something that's not 90 degrees. That was red, that didn't work. Let's try and color, see if we can make yellow work. All the other thing I might say to Robert, make it sort of in the middle of your paper so that you got plenty of room to work with. Make it big too. Look, you didn't even use a third of the paper. Make it a big angle. So you got your angle. Maybe my angle looks something like this. What am I going to label this point right here? Point A. So do that. Put a point right there at the vertex and label it point A. Number 3, measure your angle. What do we use to measure angles? Protractor. When I go to measure mine, what you do, see the little hole? That's what goes, that matches up to the vertex. So you match up the little hole with the vertex, then it's got these crosshairs. Match that up with one of the sides. So if I match mine up, I put it right on my vertex, and I match up this side, the other side of the angle comes out up here. And it gives me two numbers. My numbers look like they are about 44 degrees and 136 degrees. Now, yours doesn't have to be the same as mine. Which one of my numbers is the correct measure of my angle? Why 44? How do you know that? It's the acute angle, right? So I know it has to be the smaller number. If you made an obtuse angle, then yours would be the bigger number. If you made an acute angle, then yours would be the smaller one. So get rid of one of those numbers. You only need one of them. It only has one measure. If you drew an acute angle, use the smaller number on the scale. If it's an obtuse angle, use the bigger number on the scale. Choose the wrong one, Levi? You know now, right? Wow, I taught you something. I'm so proud of myself. Once we have that done, we're going to do this. Take your compass, spread it out a little bit. Don't spread it out like this. That's not going to do you any good. Don't spread it like this. That's not going to do you any good. Somewhere in the middle. And all you're going to do, put your point. Get it measured good. Put the point right on the vertex. Just line it along the bottom. Line it up with one of the sides. So it comes out right there. Come up here. And it goes like 124. 4. And then the other way, 56. Alright, well, did you draw the acute or obtuse angle? Yeah, you did. Acute's the smaller, right? So that's an acute angle, so we don't want the 124. So it has to be the 56. It was 56, right? I think it was 56. Put the point right on your vertex. Sort of hold it in place so it doesn't move around. And you're just going to make an arc. If I could ever hold mine. You're going to make an arc across your angle. So it's going to look something like this. Nothing real difficult. It'd be out a little farther, in a little farther. You don't want something way down here. That's not going to help us. We want an arc going all the way across the angle out there a little ways. Over here, use the other hand. I'm not going to do it for you. Hold this here, this hand here, right there so it doesn't move. This hand up here, and just turn. It's working. Make sure you go through both sides of your angle. What are the sides of an angle again? This is a what? Ray. This is a ray. Next thing you do, where it crossed your angle, put a dot there, put a dot there. Label one of them B and one of them C. So now you should have some angle on your paper, whatever it looks like. It looks something like this: A, B, C. With the arc going through the whole thing. Now, if you switch to B and C, does it matter? No. Alright, now to name the angle. To name the angle, guess what the symbol for an angle is? A little angle. That's real hard. Now, again, it's a little different than lines, rays, and segments, because instead of going over top of the letters, the angle symbol goes out front. So you use a little angle symbol, and there's two different ways you can name it, and we're going to talk about these here in a minute. You could name it with one letter. Which letter do you think we're going to use on our angle? A. So you could name this angle A. That's one possible way. I don't really like using that method, and we'll talk about why here in a few minutes. Better way to name it is with three letters. Use the angle symbol out front of the letters, and then, how do you think? A, B, C? A, C, B? B, A, C. Why did none of the other ways work? Guess what has to be the middle letter every time? The vertex has to be the middle letter every time. Alright? So it's CAB, would that work? Yeah. So what it's doing, it's like you're starting here. If Chloe wants to name it CAB, you start here, and you're walking around the angle. And you just name the letters that you cross. What letter did I cross first? Then I got to, and then I got to, and that tells somebody what the angle is. That makes sense so far, Julie? Everybody have that much? Nothing too difficult so far? All right, now it gets a little harder. All right, with your compass at point B, draw an arc on the interior of the angle. Where's the interior of your angle at? Dustin, point at the interior of your angle so everybody can see where it's at. Inside the angle, right? So it's going to be inside his angle, in here anyway. All right? This is what you're going to do. Once you set this, don't move it again. All right? So if you set it this wide, leave it there for these next 2 or 3 steps. Don't. So if you set it and then do this, then you messed up. All right? So set it somewhere, fairly, again, not real small, not real huge, somewhere in the middle. You have your angle. And all you're going to do, got A here, B here, C here. You're going to put the point of your compass right there on B. Put the point on B. Now, if I put the point on B, do I want to draw my arc out here somewhere? No, that's on the outside end. I want my arc to be somewhere in here. So my arc's actually going to look something like that maybe. Just somewhere on the interior, draw an arc. Don't make it real small, doesn't have to be real huge. Then as soon as you get done doing that, what are you going to do? Instead of putting your point on B, you're going to put it on C, and you're going to make another arc. All right, and the other arc, if it goes off the paper, then you might have to do what to your compass? Make it smaller. You'll be all right. Just come back this way. So draw an arc. Now, don't move it. Go to the other side and do the same thing. What should happen with those 2 arcs?
They should intersect.
They should intersect. Now you may have made yours. Yours might look something more like this, where they intersect at 2 points. All we really care about is this point out here. Yeah, see. So we want to take that point. Do what? You got to sort of turn it a little bit. Turn it like sideways. Or sideways, and then that's going to work a little better. When you're right on the tip of it, then work Now do one. Now do one from the other problem.
So I just draw that.
Yep, except we want this point up here.
Darn.
So you move this. So we want to just take this. Now you got a point right there.
We're supposed to do this right now?
Yep. You just draw it upwards so that it crosses this one that we drew a second ago. Yeah. Perfect. That's all you need to do. Get that point where they intersect. That's what you want. You take that point where they intersected, this point right here, where they intersected, and you label it what? D. So put a D out there. Then what do you do? Take your ruler, draw a ray from A through D. Take your ruler, draw a ray from A through D. And something that looks like you're maybe just moving on. Yeah, it's a little off. So set it at this one. So that's about the same. Now we can only do it to do it. All looks like half, and some of them, the compasses are, sort of cheap. They don't hold, so if you probably laid it down and when it hit the desk, it moved just a little bit. All right, now once you've done that, so you've got this angle, if it helps you, because it looks all cluttered and everything, you got an angle with two rays, these arcs in here, and the arc that you got going across this way, take your eraser and erase those arcs. All right? So that all we have left is this. It might make more sense to you. If those extra arcs don't bother you, then don't worry about it. It's not a big deal.
So we're just measuring, like.
Now you're going to measure this angle and that angle. So measure because now how many angles do we have in this picture? Three angles. We got the big one, and we got the two smaller ones that we cut them up into. Now you want to measure those two new angles. Get it close.
That's like 25 right?
I like these.
More of a spread. Since you made your angle so big, you just need a wider spread here. Take this. Like that. This. Here. That. Make that point D right there. Now take the ruler, draw a ray from A through D. They're both the same thing, 25. So put 25 in there, 25 in there. You want that? Alright, so you measured this, it was 128, the whole thing, right? Do this. The rays, so we want arrows. Otherwise, it doesn't look like it. Now you're going to do is measure this angle, turn it around, measure this angle. Does that make sense? Anybody figure anything out? When you measured them, what happened? What was my angle? My original angle was like 46 degrees or something, wasn't it?
It was 44, wasn't it?
I was thinking it was 46. Alright, whichever. So 46. If that was the case, Looking at yours, what do you think this angle would be if I measured it? 23 degrees. How about this angle down here? 23 degrees. What did this ray do to that original angle? Cut it in half, split it in half. And that's going to be something special that we're going to talk about. You got different numbers? If you got, were they sort of close? All right, if they're sort of close, probably what happened is when you were drawing your arcs with your compasses, it probably moved just a little bit. And if it moved just a little bit, that would have messed up everything. That's why we had to keep this exactly the same. Now, if you were way, way off, like if one angle was 20 and one angle was 60, now then you did something completely wrong and I'd have to go back to it. But if I look at Robert's here, does that ray look like it splits that angle into two angles that are the same? Yeah. That's sort of what your picture should look like. All right, now last thing I want you to do, name the 3 new angles. So right there on your paper, name all 3 angles. You've already got one of them named, don't you? Yeah. So name the other 2 angles. Name the other 2 angles. I'll give everybody a hint. What's going to come first? The angle symbol is going to come first on both of them. Somebody name this angle up top for me. Angle BAD. What's another way you could name it? DAB. Name the bottom angle for me. DAC. Angle DAC. Everybody agree with that? What's another way it could be named? Angle CAD. Angle symbol first, then the 3 letters. Please make sure, this is why we said that the original angle could have been named angle A, right? But if we look at this picture now, somebody want to come up and point out which angle is angle A? That's why we don't want to name it with 1 letter. Okay, because if I say angle A, do you have any idea which angle I'm talking about in this picture? No. So that's why we don't want to name these angles with 1 letter normally. It's not as good a thing. Use 3 letters, the angle symbol goes out front, vertex always in the middle. All right, stick that off to the side. Grab your notes back out. Three terms, congruent angles, angle bisector. I guess the last one's not really it's how to name angles. All right, congruent angles. Congruent segments were segments that had the same length. Congruent angles have the same degrees. To just say congruent, having the same measure. So here we're just going to say angles having. Notice I'm going to use this angle symbol. You probably never see me write the word angles out again. Start using your symbols. It makes everything a little shorter, easier to write. Angles having the same measure. Angles that together have the same measure. So if I tell you one angle is 60 degrees, what's the measure of an angle that's going to be congruent to it? 60 degrees. What you just drew there on your paper was an angle bisector. What did it do to the angle? split it in half. Now what we're going to do is actually give a better definition for it. Because if we start saying cut it in the middle, cut it in half, doesn't really say what you want it to say as far as the math goes. What kind of thing was it? What was that? Array. So that's what we're going to start with. Very good. A ray that, what did it do to the angle? Splits an angle into two. I'm not going to say equal. I'm going to say, what's the geometrical term for equal? Congruent. So two congruent, and we'll say angles here, just because it's easier to write than parts. So a ray that splits an angle into two congruent angles. What do you think a segment bisector is? All right, so it's anything, it could be a point for a segment, splits that segment into two congruent segments. All right, naming an angle, I'm going to draw an angle up here. Might be helpful if you drew it. Q, M, A, doesn't matter what the letters are. Ways to name angles. There's three different ways. First way is with one letter. How would I name that angle with one letter? One letter. Angle, making sure you use a symbol, Q. Don't forget the symbol for an angle is a little angle, real hard. So that's one way to name that angle. Second way to name that angle, three letters. Still with me back there, David? Still with me? You sure? Been doing so well. Don't screw it up now. Three letters. Angle A, Q, M, or what's the other one? Angle M, Q, A. Sorry, my thing is going off the screen there. Angle M, Q, A would be the other way with three letters. What do you have to remember when you're naming it with three letters? Vertex in the middle. So here for this one, for three letters, vertex is middle letter. Vertex has to be the middle letter. Now the third way, there's one other way to name an angle, and we haven't talked about it yet, but as we go through the year and the book gets lazy and we get lazy and you want to name it an easy way, this is what the book will do. They'll put a whole bunch of angles on the picture. Might look something like this, if I could ever draw it straight. Might look something like that, and instead of using three letters because it takes up more space and more time, they do something like this. They put a number right there in the vertex. So the other way we could do it is just by using a number. This angle then would be called angle 4, with the angle symbol and the 4. And it's just an easy way to do it. What if I put an R right there for that vertex? Can anybody come up and show me where angle R is in that picture? There's too many angles there, right? If I just say angle R, you don't know which one. So if you have a picture, this only works when there's only one angle in the entire picture. If you have more than one angle in the picture, then you can't use one letter because you're not going to know which angle you're talking about. All right, look at number 10 on page 33. So open up your books. I think number 10 is actually part of your homework. So you might want to get out a clean sheet of paper. Number 10 on page 33. If it's out of order on your homework, it won't matter. You see that? Number 10. Before I go any farther, what kind of angle is that angle right there? What do you know about the measure of it? 180 degrees. Everybody tell that that's a T. Didn't want to draw. Right there. That looks a little bit. S right there. All right, we're going to do a whole lot with angles this year, so you got to know how to do this basic stuff. They tell us, they give us this picture, and they say in the figure, QP and QR are opposite rays. So QP, QR, opposite rays, so we know that that whole thing is 180 degrees because these two are opposite rays. All right? And QT, this ray right here, bisects angle SQR. So what's it do to that angle right there? What do we know about these two angles? They're congruent. So what I'm going to do is mark them with the tick marks like that to show that they're the same. Then they tell us, if we look down number 10, the measure, and anytime you see this, measure, watch carefully, this confuses a lot of people. M, angle symbol, TQS, all that means is measure of angle TQS. So that's red, measure of angle TQS. So measure of angle TQS, that's this angle right here, is, oh no, it says find the measure of angle TQS. If the measure of angle RQS, that's this whole angle, so from here all the way around to there, so that measure is, somebody help me out in the book so I don't have to keep looking back. What was that, 22A minus 11? 22A minus 11. That's that whole angle. Then the measure of angle RQT, that's this angle. 12A minus 8. This angle's 12A minus 8. What's this angle over here? 12A minus 8. So since we know these two are congruent, if that one's 12A minus 8, we're going to put 12A minus 8 over here in this other one also, since they didn't tell us anything about it. So both these are the same, both 12A minus 8. If I turn from here to here, I turn 12A minus 8. If I turn from here all the way around to there, how far did I turn? Can we set up an algebraic equation from all that information? Just like with the segments that we've been doing. This segment plus this segment should equal what? The whole thing. This angle plus this angle should equal the whole angle here. So 12A minus 8 plus 12A minus 8 should equal how much? 22A minus 11. This plus this should equal that whole thing. Like terms, what's 12A and 12A give us? What's 12A and 12A give us, Julia?
24A.
24A. What's a -8 and a -8 give us, Wade? -8 and a -8. So -16. 22a minus 11 on the other side. What do we do next, David? David! With me? Look at our equation. What do we do next? Now, we don't want to take the 24a to their side. Probably better to do what? Take the 22 over to that side. Just to keep it positive. It doesn't matter. If you did it the other way, it'd come out the same. What is 24a's minus 22a's, Dustin?
2.
Got 24a's, you take away 22a's, 2a. We still got the minus 16 on this side. Those canceled. We got minus 11 on the other side. What do we do next, Chloe? How do you solve that? Add what? Add 16 to both sides. Good. All right, Levi, what's -11 plus 16? Got $16 and you owe me 11. How much you left with? Close. 5. What do we do next?
And then you divide by 2.
Divide by 2. Max, what's 5 divided by 2? 2.5. 2.5, 2.5, whichever way you want to write it. Now be careful, is that our answer? No, what they ask us to find. Go back to the problem, and it said find the measure of TQS. We're trying to find that measure. So we look back at that angle, TQS. TQS is right here. How are we going to find that measure? What do we got to do with that A that we just found? Plug it in there. So 12 times, somebody with the calculator help me out. 12 times 2.5 minus 8. You got Chloe's calculator here. She can punch the whole thing into her calculator all as one thing. So just do this. Turn it on. 12 times 2.5 minus 8. And it equals, and it gives you the final answer. It does it all for you. TI-30 does the same thing. Any of those calculators that print across the screen. What did it say, Chloe? 22? So what's the measure of this angle right here? 22 degrees. What's the measure of this angle? 22 degrees, because we knew that they had to be the same. What's the measure of this whole angle? 44. Now let's look at this. If I was to redraw this picture, our picture looks something like this. We know that this is 22, this is 22. Could we find this angle over here even though they didn't tell us anything about it?
Yeah.
What do you know about all those angles together? They should all add up to 180. So Chloe can take her calculator right now and say 180 minus 44. One what? 136. Does this angle right here look like an obtuse angle? Yeah. So we found every angle in that picture. How many angles are there in this picture? More. Name me an angle in this picture. PQS, that's one angle right there. SQP, that's the same angle, right?
No, T, not
Oh, SQT, that's this angle, okay. SQR, that's those two together. TQR. Say it again. PQR, that's the straight angle, right? Give me another one. Still more. How about angle, what if I ask you to find the measure of angle PQT? Is that an angle? Goes like this.
Yes. Oh, yeah.
All right? So there's 6 angles in this picture. You got to be able to pick all those out. And to find that, you'd have to do what? 22, and what did we say this was? 136. At 22 and 136, that'd give you that whole thing there. Skipping that. All right, look at problem number 39. 39, flip over. Again, I think this is part of your homework. So problem 39, give me just a second to draw the picture up here. You've got to make sure on your paper, you need to be drawing these pictures so that you can label them and do all the stuff that you need to do with them. Notice that they stuck 1 and 2 in here to make it easier to name. Make sure, don't move. Make sure you go back, fill in the things. I'll check it next time. Do your reflect, do all that. I'll check it. Start a class on Thursday. Your assignment is page 34, 12 through 40, the even numbers, 50 through 54. If you don't write it down right now, it's on Moodle. And make sure all my stuff gets back up here into the box or wherever it belongs. Make sure you got that assignment down. Don't come in next time and say, oh, I didn't do it because we were so late. Tristan didn't do his job.
I know, sorry.
Right on problem 39. They give us a picture, it looks like this. I'll write this up here real quick. X. X. Y, Z. And they tell us that YX and YZ are opposite rays. So that means this right through here is going to be a straight line or a straight angle, 180 degrees. And they tell us that YU bisects. So YU, that's this ray right here, bisects angle WYZ or ZYW, whichever way they name it. So that means that these two angles are congruent to each other. And they tell us that YT, which mine doesn't look like it, YT bisects angle XYW. So these two angles are congruent to each other. And in problem 39, it says if angle ZYW is a right angle, ZYW, this whole angle right here, if that's a right angle, when my picture really looks off, if that's what they're saying. So that whole angle is 90 degrees. And the measure of angle ZYU, that's this angle right here. Measure of angle ZYU is 9B minus 1. I know, I'm sorry, wrong. 13A minus 7. So this is 13A minus 7. That's that angle ZYU, that's that angle right there. Find A. So this time they actually just want us to solve for A. So once we get A, we'll be done. Well, if this whole angle is 90 degrees, and we knew that this ray right here bisected the original angle, then that means these two are congruent to each other. Well, if they're congruent and the whole thing's 90, then each one has to be 45. So this 13A minus 7 should equal 45 degrees. Solve that, add 7 to both sides, end up with 13A equals, what is that, 52, divide by 13, you end up with A equals 13 again, 52 4 times, so A equals 4. And again, that's all they asked you to find this time was A. They didn't ask you to find any of the rest of the stuff. You could have found some of this other stuff. I mean, we could have figured out that this angle was 45 degrees. We know that this whole thing here should be a straight angle, which is 180. So if that's 40, if this part is 45, this part's 45, then and these other two parts over here are congruent. That means they got to be 45 also. That means angle XYW should have been a right angle also, which again in my picture it doesn't look like it, but don't go by what my picture looks like. They didn't ask us to find all that. All they asked us to find was A equals 4. All right, your assignment is on page 34, 12 through 40 to even numbers, problems 50 through 54.